you actually saw this in action on Friday. Okay? Let's review what you did on Friday. Watch this. You took, on Friday, if you were here, anybody absent on Friday? Besides Sarah, just Sarah? Okay. You took about 2 grams of the sodium hydrogen carbonate. You put it into an evaporating dish. I'm going to put it into a beaker so you can see it.
Is that 2 grams?
It's about 2 grams. I'm a pretty good estimator. Now it's 2 grams, okay? You happy now? That's 2 grams. You added acid to it. Now, I know it was a short period, so I didn't make you do certain things in this lab that I normally would. You add a little acid to it, poured it down a stirring rod, it fizzed, you stirred it up, you waited till it was done, poured some more in, it fizzed, you stirred it up. It was a shortened period because of the 2-hour delay schedule, and we had to really rush. So I didn't make you write down observations, and I didn't make you write down sources of error. I just had you do the calculations. All right? Well, if I had asked you to do sources of error, this is exactly what you guys did, right? Let me ask you something. Because I know someone would have put this as a source of error if we had time. Give me some sources of error in this lab. Adding what? Adding too much acid. The answer is no. I told you not to add too much acid because I didn't want to fill the room up with the fumes from the hydrochloric acid. But it would make no difference at all to your results. Wouldn't make any difference to your percent error. Let me show you. It's done fizzing now. Say I go and add more acid. Am I making any more salt? Why not? Why am I not making any more salt by adding extra acid? There's no more sodium bicarbonate to react with. Okay? It's out of it. So I can add all the acid in there I want to. It doesn't make any difference. It's not going to make any more salt. You know you made salt at the end of this lab. What will happen to that excess acid? What's going to happen to it when you put it on the burner and you burn it off? It's going to evaporate, right? Now, why didn't I want you to do that? I didn't want you to do that because the hydrochloric acid fumes, you smelled them. Anthony smelled them very well once. If you put your nose right over that, it went right up your nose. However, it would not make a difference at all in your answer to the percent error. Okay? Why? Because of limiting reactant. Look at this little picture here. Okay? Turn that light off, you can see it a little bit better maybe. Say I work at McDonald's, which will be the future jobs for most of you. It's funny. Certainly for Caitlin. Now, I work at McDonald's, and I'm told, this is my supplies. I go in the back, and that's all we've got left. We've got 3 hamburgers left, 4 buns, this many pieces of cheese, and that many tomatoes. Now, every hamburger, to make a cheeseburger, has to have 1 of each, right? How many cheeseburgers can I make? 3. Only 3. It doesn't matter that I have extra hamburger buns. It doesn't matter that I have extra cheese. I could ask for extra cheese. It doesn't matter if I have extra tomatoes. Okay? I can only make 3 complete hamburgers. And then all this other stuff is left over. It's excess. So my limiting reactant is the guy who is in the least abundance. Just like, turn the light back on, my limiting reactant in this case was this. It made no, did you notice I didn't even measure out how much hydrochloric acid? You never measured it out, did you? Yet we were able to do a very accurate lab. Most of your percent errors were somewhere around, 5% or 10% error, except for, I saw a couple of bad ones, but, 52 would be a bad error. Is that what you had? Jackson had 52. What'd you do? Eat the salt? We popcorn lab and the salt lab together. We just put them together. Just put a little salt on our popcorn. Now this, I only had to measure the mass of this guy because he's all that matters. Just like I only had to know how many hamburgers I had because that's the one I had in least abundance. Doesn't matter how much extra I'll have with these other things. Okay? All right, you got the idea? That's limiting reactant. And that's what I'm going to illustrate a couple of examples for you right now. And you may see one harder one as a problem as an extra credit problem, possibly. Anyway, get your notes out. And the limiting reactant, what is it? It's the reactant, as I just explained, that's in least abundance. By the way, the least abundance has to be moles, not necessarily grams, but rather moles. Because after all, the coefficients go by a mole ratio, not a gram ratio. Okay. All right, let's take a look at some examples, because that's pretty much the notes. I want you to circle the limiting reactant in this reaction if I give you, this, by the way, is the exact same reaction we just did, right, on Friday in the lab. And I just did it right here in front of you in the beaker. Copy that guy down. That's the reaction for it. And it's nice because I start off with an easy one. I always start off with easy examples. All the coefficients are 1. I'll give you a nice easy number, and it will be obvious who's the limiting reactant in the first example. It won't be so obvious every time, though, as we go on, and I make the problems harder. Okay? Let's see what we got here. Say I tell you you've got, we mix together 1 mole of sodium bicarbonate, so sodium hydrogen carbonate, and 1.5 moles of hydrochloric acid, which is probably about what we did in the lab, although hopefully we didn't add that much extra hydrochloric acid. But it's similar to what we did. Who is the limiting reactant? I want you to circle it. That's what I'll ask you to do on the test. There'll be probably only 1 or 2 of these on the test. Okay? And they'll be incorporated into the chart problems. Okay? So let me ask you, who am I circling here? Who is my limiting reactant? Who's the guy in lesser abundance? Marie.
The one on the left.
Which is? Which compound?
NaHCO3.
Okay, so the 1 mole of NaHCO3 is my limiting reactant. It's a smaller amount. All agree with that? Okay. So how much salt will I get from that? This goes back to stoichiometry. Now we're back in stoichiometry. Remember I told you we had finished pretty much everything we did. This is the only new thing, and it's not really new. How much salt will I get from that then? What's the answer to that? Michael? 1.0 moles. Yeah. And how much water will I get? 1.0 moles. And 1.0 moles of CO2. Why? Because the coefficients are all 1. So the ratio is 1 to 1 to 1 to 1 to 1. All right. If I had asked how many grams of this or how many grams of that or how many grams of that, it would be a different story. But I didn't. I just asked for moles. All right. Well, what if I did this? I'll give you a couple of more choices here. I could make it the numbers a little bit harder. But I mean, come on. That's not that bad. This time, who's the winner? Who is the limiting reactant? This time, I have less hydrochloric acid than I have of this. So when I run out of hydrochloric acid, the rest of that sodium bicarbonate is just going to sit there. Okay? So he's my limiting reactant. And you realize, this is what I'm going to illustrate the point here. How much of each of the products now are going to be made? How much salt will I get from this second reaction then? What do you think, Rupesh?
0.45 something.
Absolutely not. Who's the limiting reactant, Rupesh?
0.21.
Yeah, we circled him. See, this is my, I told you, and the reason, a lot of times people look at these and say, why'd you even do one? It's so easy. That's why. The point of the limiting reactant is very simple. It tells you who to use and who to ignore. Did you all hear that?
Yep.
The point of the limiting reactant is tells you who you're going to use to predict the other guys and who you're going to just ignore because there's excess of him. You see? This guy's going to be 0.214, 0.214, 0.214. Got it? Pretty easy. But that's why I do more than one. And I can make it more difficult. How can I make it more difficult? Give me a couple of ways I can make it more difficult besides the numbers. I could throw coefficients in there. And what else? Could happen.
Units.
Yeah, the units. It could be grams. Could ask you about grams. So that could be a problem. All right, so let's keep that in mind while we do the next couple. Try this guy. Now I've got a coefficient in this one. Copy him down and think about what would happen if I added that amount of each of those. Because it's not quite what you might think. Okay? Everybody figure they got it? Let's see. Who's the limiting reactant? Now, the obvious answer would be magnesium. There's less of him. But is there? No. Here's why. Let's go back to my analogy with hamburgers a minute ago. Okay? I could probably get back to that guy. Hold on a second. I didn't think about this. Let's go back to this analogy, okay, with the hamburgers. All of these assumed there was one of everything needed, right? One hamburger, one bun, one piece of cheese, and one tomato. But let's say each one had to have, I need green, had to have 3 pickles on them. So let's just say I had 1, 2, 3 pickles. 4, well, actually, if one has to have 2. So I have 1, 2, 3, 4, 5, 6 pickles. Who's my limiting reactant now if each hamburger has to have 3 pickles on it? Who's my limiting reactant? How many hamburgers can I now make? 2. I can only make 2 hamburgers. You can't even see those pickles, by the way, on the video I'm looking over here. Let's make them in red. Red pickles. You ready? Red pickles. 1, 2, 3, 4, 5, 6.
Are you gonna die if you eat that?
Yes. Do not eat the red pickles. Just saying. All right. So you've got 6 pickles. I've got more pickles than I've got anything else. Yet he's my limiting reactant. How come? Because every hamburger has to have 3 pickles on it.
Actually, 7 tomatoes.
Did I make 7?
You have 7 tomatoes.
Oh, I have 7 tomatoes? Okay, whatever. Okay? So, it does matter how many are used. It does matter. That's like the coefficient. What's the coefficient in the problem? So let's see what happens in back to my problem here. Come on, come on, come on. All right. So here's the thing. I have 1 mole. For every 1 mole of magnesium, I need 2 pickles. I need 2 moles of this guy, don't I? Well, I've got 1 mole of magnesium. Do I have my 2 pickles? No, I only have 1.5. So who's my limiting reactant in this case? Be careful. Who's the limiting reactant again? Hydrochloric acid. And this guy, I don't have enough, do I? Okay, so he's my limiting reactant. Did I hit the button yet or no? He's my limiting reactant. Now, can I go from there to get the other guys? Yeah. What's it going to be? Is it going to be 1.5, 1.5 again? Only for people who are literal. From the last example. Look, 2 is to 1 as 1.5 is to what? 0.75. You got it? Moles. See that? And then 0.75 for this guy. All right, so let's put them together to another couple of examples here. We're almost done. What about that guy? Can you figure out who the limiting reactant is in this case? I'll show you a little trick after we're done with this one. Okay, who knows what the limiting reactant is this time? Sarah.
Magnesium.
Exactly, it's magnesium. All right, was everybody thinking that? I hope, and you're right. It is magnesium. All right, let me show you the trick now. I think let me one more time explain it. This will be the fourth time just using common sense, but then I'll show you a nice little trick. Again, just explaining it. I need twice as many HCl's as I have of Mg's. Twice as many. I have 2 of this. That means I need 4 HCl's. Do I have 4 moles of HCl? Yeah, I got more than that. I got more HCl than I need. So he must be my limiting reactant. That's the common sense one. Now, can anybody figure out what's a thing I can do to these when my numbers get uglier and my coefficients get even worse? What can I do to tell who the limiting reactant is? Anybody figure it out to these 2 numbers? What do you think?
How many moles you have, you divide by that coefficient.
Yes. If I just divide each of them by the coefficients and whatever's a smaller number, wouldn't that work? Does that make sense? 2 divided by 1 is a 2. 4.5 divided by 2 is 2 point whatever, 2.25 or whatever, right? So whatever's the smaller of the 2 numbers, when you divide by their coefficients, that's the limiting reactant. Now that doesn't tell you anything except who to use. It tells me to use this guy. Now I still got to use stoichiometry to do the rest. 1 is to 1 as 2 is to 2, right? 1 is to 1 as 2 is to 2. That look good there, everybody?
Yes.
I told you it's an easy concept. Last concept we're doing in this chapter. And the last concept before the midterm. All right. Do I have any more examples of this one? No. I got one last one for you to do on your own. And I can make it also hard. I can also make it more difficult by not finishing the equation for you. Finish that equation and then tell me what happens in this case. That's about as tough as I can make it. About as hard as you'll see on the test, with the exception of a possible extra credit. And it's also the last one I'm going to do. I will, however, hint towards the extra credit and give you a problem that includes it on homework. You got to finish that equation, you got to balance that equation, and then you have to divide and figure out who is the limiting reactant, and then finish the chart. Let's see how we did here. Everybody get aluminum sulfide, right? Okay. And everybody, I hope, wrote Al plus S yields Al with a plus 3, S with a minus 2. Yeah, you got to still write and use the charges. And therefore balance them with a 3 and a 2. All right. Now, this was not one I think you could see off the top of your head. That's why I gave you this one. Okay? Kind of have to do what I told you, my little hint I told you about. 4 divided by 2 is 2, correct? 5 divided by 3 is what? How much? 1.6 repeating, I think, or something like that, right? Okay. So who's in lesser abundance? This guy. He's my limiting reactant, even though there's more of him, because I need 5 pickles instead of 4. Okay? And finally, what do? I use that 5 to do this guy. 3 is to 1 as 5 is to 1.666 or whatever. Is that right? Repeating. So with 1.7 if you round it off to correct significant figures, and right number is 1.7 moles. Okay? Last thing I'm going to hint at, give only as a bonus on the test, but you will see it. see how well you could do. I'm not going to have you do it, but say I gave you 2.7 grams of aluminum reacting with 3.1 grams of sulfur. What would you have to do first? The only thing that will make it different. Yeah, you'd have to convert to moles first. Now, you don't have to do that, but I'm telling you, that's what you'll have to do in one problem on the homework tonight, 25. Everything else, 19 to 24, are like the other ones. They may not be in a chart format, but they're like these, where it's moles to moles to moles, all moles, okay? All right.